Good morning, friends. I want to first apologize that this video is up late today. It has been an interesting morning in that I couldn't get my materials to print. I couldn't find very many of the objects needed for this experiment, but I think that it will be a fun experiment regardless of what you're able to find in your home. And I mean, I know a lot of you are writing answers on scratch paper too, so just bear with me. I'm sorry that we're so low tech today. We're all doing the best we can, aren't we? All right. The first thing that I want to do is I want to let you know that what we're going to be talking about in science for the next couple weeks is something called force and motion. So what does that mean? Let's talk about some of the vocabulary words that we're going to be talking about during this unit. So we have the words force, motion, hypothesis, experiment, outcome, conclusion, and vigorous. So, the word force, that means that something has the power or energy. So when in this experiment, the force is going to be us. Kind of funny, I wore my Star Wars shirt, the force. I did that on purpose. The force being put on is going to be us pushing objects. Okay? So we are the ones that have the power, or we're the ones exerting the energy. The word motion, that means the action or the process of moving. So the thing that's going to be showing us motion in this experiment are actually going to be various ball-shaped objects. It would have been great if I had a soccer ball, if I had a basketball, if I had a bowling ball, if I had a football. But unfortunately, as hard as I looked, I came up with what I came up with, and you'll see in a little bit what those things are. We're improvising today. The next vocabulary word is hypothesis, and we talk about this all the time. It's kind of interchangeable with the word prediction or an educated guess. A hypothesis is exactly that. It's an educated guess. What does that mean? It means you're taking information you already know. You're taking information that you suspect is accurate, and you're applying that to the situation that you're getting ready to conduct, and you are sorry, Rosie, the dog, is distracting me. I'm going to have to put her away in just a second. You are deciding what is the most accurate as far as what you know. Give me 1 second, I'm sorry. Sorry about that. The next word is experiment. Experiment is a test done to see if a prediction is valid or true. So after we've made our hypothesis, that information is not good enough. We have to put our guess to the test. We have to figure out if we are correct or not. We need to use science to determine what the correct answer is. So it's a test done to see if your prediction is valid or true. An outcome. An outcome is a judgment. Sorry, no. An outcome is, sorry, my computer is also very slow today. I just want to give you the exact definition that's in the activity. That's why I'm looking. An outcome is a possible result in an experiment. So an outcome is, I'm trying to think of experiments that we've done at this point. An outcome for the PEEPS experiment, if you did that. If we put the PEEP in the microwave, the outcome of that experiment was that the PEEP expanded and burned. When we put the PEEP in the freezer, the outcome was that it hardened. It really didn't shrink very much. It definitely didn't get bigger or anything, but it definitely was a lot tougher. So an outcome is a possible result of an experiment. Conclusion is what I was starting to give you a moment ago. A conclusion is a judgment or a decision reached by reasoning. So you've got your educated guess. I think that this is what the answer is going to be. You've done your experiment. You've practiced, using science to either prove your hypothesis true or to find a different outcome or result. And then your conclusion is going to be, okay, for sure, if I put a PEEP in the microwave, it's not going to look the same when it comes out. It's going to expand, it's going to burn, it's going to taste a bit more charred. The word vigorous is something that's going to apply to maybe the amount of force that we put on objects in this experiment. So vigorous is like exhibiting strength, so showing strength, like a powerful force, energetic, so like Rosie, and intense. Okay, so what we're going to start with is I'll kind of show you what materials you want to have. Now again, I already uploaded the experiment directions and worksheets and things onto Google Classroom last night. My printer wasn't working. Hopefully yours does. If not, scratch paper works just fine. So what you want to do is you want to find 1, 2, 3, 4, 5, 6 different types of sport equipment if you can. I found 6 objects, but again, we're improvising today. So the materials that I have are a softball, a tennis ball, like a koosh ball or a stress ball, a cotton ball, a pom-pom ball, and this one's a stretch, an Easter egg. I wanted to find something that wasn't exactly round, thinking about like a football shape, but obviously this isn't as dense or as heavy as a football. We're just gonna go with it. We're improvising, and that's fine. Force of motion will work just the same. So what we're going to do is we're going to write down the names of our objects here. All right, so I have a softball, tennis ball, cotton ball, stress ball, pom-pom, and an Easter egg. So 6 things. If you can't find 6, it's fine. Just try to find more than 2 or 3 if you can, because as in every experiment, you want to have as many different sources of information coming in so that you can get the most accurate result. You're limiting yourself if you only have like 2 or 3. Before we can start our experiment, the first thing we need to do is we need to come up with a hypothesis. So which of these balls is going to need the most wind force? We're going to be the wind force today for motion. So which of these is going to be the most difficult to move by like blowing on it? Which one do you think? I might pick them up and see how heavy they are. Notice the different barriers, so like the ridges on the softball or the fact that this is shaped differently. Well, The softball is definitely the heaviest of the ones I have here. And I think the ridges also might prevent it from moving easily. So I am going to make my hypothesis for the ball that will need the most force to move as the softball. Now, I can't just write the softball. No, no, no. We're better scientists than that. We have to explain why. Explain your reasoning. The softball because it's heaviest and its stitches might get in the way. Well, it's moving. All right, we need to come up with a second hypothesis. We need to figure out which of these objects is going to need the least amount of wind force for motion. So I don't think softball, because I already said that's going to be the most difficult. Tennis ball, it moves pretty easily. Egg is light. Cotton ball, I don't know. Pom-pom. You know, I think it feels like the Easter egg is the lightest. And I also noticed that its exterior is the most smooth. So it doesn't have things like stitches or, rough exterior to get in its way of moving. So my hypothesis is going to be that the egg, the Easter egg, will need the least wind force because it's lightest and smoothest. So nothing's in its way. Now, the problem is its shape. Its shape might be a factor, but we'll see. All right, we've made our hypotheses. We've written down our different objects. Before you move on any further, you need to kind of draw a scale. And on the worksheet, it has a scale for each of the different objects that you have. But I think that if you're writing on scratch paper, it's perfectly fine to just have a scale, one scale drawn. And then what you can do is you can give each object a number if you have small scratch paper like I do. Or you can just simply write the object on the scale where it fell. So we're trying to figure out, compared to each other, which of these objects needs the softest form of wind motion or the most vigorous form of wind motion. Now remember, vigorous means that you're putting more energy into it. It's taking more effort. It's more difficult. So I'm going to try to make it so that you guys can see what I'm doing. Okay. So let's start with the softball, since I've written that one down first. Hopefully this won't roll off the table. Okay? Just setting it here. All right. How easily do you think I'm going to be able to blow this across the table? I think it's going to be hard. I don't know if I'm going to be able to do it. All right, let's find out. Don't judge me. Did that really move? No, and it didn't even have a chance really to roll to where the stitching is. So the stitching really didn't become as big of a factor as I hypothesized. It's just dense. It's too dense for my lung power to push it forward. You saw it kind of roll a little bit, but that's about as far as it went. It didn't really progress. It didn't move forward. So if I had a scale here, would I put the amount of force that it's going to take to get this softball to move, would it be a soft force or would it need to be a vigorous force? I think that the softball, which I numbered 1, because it's our first in the experiment, I'm going to put it right here. It's right here on top of vigorous. Number 1. That's where it falls for me. Done with our softball. Let's try our tennis ball next. That's the second one I've written down. So this is number 2. What do you think? Is this going to move further than the softball? Let's find out. Well, it went a little bit further. Was it still kind of difficult to move? It's still pretty dense. But it did move further than the softball. Does the texture of it have anything to do with that? Or is it just how dense? To think about. So is the tennis ball going to take as vigorous of a force as the softball? I think I would put it down here just a bit softer of a force, but again, it was still difficult to move. So remember, tennis ball was number 2, our second one that we tried. I'm going to put the tennis ball about right there. Okay. All right. The next one is the cotton ball. Now this cotton ball is kind of an odd shape, so I hope that's not too much of a factor. But it is very light. Do you think that it's going to go further than the softball and the tennis ball? Let's find out. Ready? Whoa! It flew off of the table. I didn't even have to do it a second time. Where would you put the cotton ball on this scale? Now, I did still blow pretty hard. Let's try it again with a softer wind force and see if it still goes as far. Okay, just the slightest little wind force. Still went pretty far. So for the cotton ball, where would you place it on the scale? So far, I think the cotton ball, the one was right over here, was soft. That was a very soft force that I used to get that to move. So number 3, I put right here where it says soft. Interesting. Wonder if our hypotheses are going to be accurate. Next, we have our stress ball. Now, the stress ball is light. It does have a smooth, exterior, but it's still a bit heavier. And it does have a ridge. So let's see if any of those things are going to be a factor in how light or vigorous of a force it's going to take to get this to move. It can stop moving on its own. Okay, ready? First, let's try soft. Did it really move? Kind of like the softball. All right, let's see if we can get it to move with a vigorous force. It rolled off the table. So it isn't quite like the softball or the tennis ball because those objects really didn't move much or at all. The stress ball, once we put a vigorous force to it, was able to go way off of the table, whereas a soft force did nothing. I think that means that it kind of deserves a place in the middle. In fact, I probably should have put 2 even closer to vigorous. the tennis ball. But it's in pen, so what can you do? As long as you're showing that, the stress ball took less vigorous of a force to get it to move, then you're recording accurately. All right, check. We've done softball, number 1. We've done tennis ball, number 2. We've done cotton ball, number 3. We've done stress ball, number 4. We've got 2 left. First up is the pom-pom. Now, the pom-pom is built kind of like a cotton ball, maybe a bit more round, definitely a bit more dense. I wonder how soft of a force we can put to this to get it to move. Let's try a very, very soft force. Ready? Went pretty far. What if we did even softer than this? Still moved. Are you ready? Let's do a vigorous force. Are you ready? Like the winds yesterday. Wasn't that crazy? All right, it shot off of the table. Now, which one do you think took softer amounts of force to get it to move? Now, you watching, you may have seen something differently, but I know that the amount of energy that I put into the pom-pom was just a bit, just slightly more than the cotton ball. The cotton ball, I put such a little force and it moved quite significantly compared to the pom-pom that still moved a good deal, but it didn't move quite as easily. So if this is where the cotton ball is, and this is where the stress ball is, where should we put the pom-pom? I think the pom-pom should probably go almost right next to the cotton ball because there wasn't a whole lot of difference. And the pom-pom is number 5. Okay. All right, one left, Easter egg. So obviously how you position the Easter egg because of its shape is going to make a difference. If I position it this way, it's not going to be allowed to move as far. It might move this way or this way. So that I can get the most accurate results and give it the best chance that it has, I'm going to position it this way so that when my wind force is being applied to it, it has the ability to move more freely. Does that make sense? So if you have a football or something at home, just make sure that you're giving it its best chance to give you results as accurate as the other objects. So you're not providing more of an obstacle in its way. Let's see if we can get it to stop moving. It's a bit staticky. Once it stops moving, we'll apply the wind force. Now, I thought, in my hypothesis, I thought maybe the egg would take the least amount of wind force. I want you to revise the hypothesis that we came up with based on what we now have seen. Do you think, I know it was my hypothesis, but we're in this together, do you still think that the Easter egg is going to take the least amount of wind force, the softest wind force? Or do you think the cotton ball might be the one that takes the least amount of force? Let's apply science to come to a conclusion, okay? All right, I'm gonna start really soft. Its shape causes it to not necessarily be able to go as far of a distance in one direction. However, it is causing it still to move. Just because it moved backwards doesn't mean that it is still not being affected by the wind force. Does that make sense? The shape of it is making it not just move this way, but this way. If you're going for a walk and you walked this way and then this way, that doesn't mean that you walked any less of a distance than if you just went completely straight. It's still going a distance. So let's try now a bit harder of a force once it stops moving. Again, it's staticky. Okay. Again, that wasn't even my most vigorous wind force. All right. I want you to see the end of the table here. Now I'm going to put as vigorous of an amount of wind force as I can. Let's see how far it goes. Ready? Okay, so that obviously went pretty far. And again, it may have looked different to you, but me applying the force, that took a lot more energy on my part than the cotton ball and the pom-pom did. I'm actually kind of surprised because when I started with the soft amount of wind force, I was thinking, wow, this is moving really easily. This might actually, our hypothesis might actually be accurate. But unfortunately, I mean, not unfortunately, we're doing science. We're coming to conclusions. The Easter egg, when I used a strong amount of wind force, didn't move as easily. So obviously this is kind of relative. We don't have the resources, materials, and things to measure it more accurately as we would if we were in the classroom. But this is for fun, and this is using objects that are very similar to each other. Whereas if we were in the classroom, maybe I'd have basketball, or maybe I could borrow a soccer ball from my friend. We don't want to come in contact with people right now, so it makes things a lot more difficult. The tennis ball and the softball are obviously the two that have the biggest difference because of their density, their size, and what their exterior feels like, the outside feels like. But unfortunately, the other objects I was able to find, like the cotton ball, pom-pom, and Easter egg, their weight, their density, they're very, very close to each other. So it is going to make coming to a conclusion a lot more difficult. So if you do at your home have objects that are significantly different in size and how heavy they are and what kind of textures are on the outside, but they're still relatively a round shape, like you don't want to use a Lego. That's not going anywhere. It's not going to give you an accurate comparison to something that's round. Try to find things that vary in size. Again, I've been searching all morning, and this is the best I could come up with, so thank you for bearing with me. Thank you for being patient as I, record this and upload this. But I am going to go ahead and say that the Easter egg, even though it was light, took a light force at the beginning, I think that I'm going to put the Easter egg in between the pom-pom and the cotton ball. Or, sorry, not the cotton ball. The pom-pom and the... Which one did I mean this to be that moves for? The pom-pom and the stress ball. Sorry, I wrote 3 twice. So that's where I'm going to put the Easter egg. Okay. So let's move down and let's see what were the outcomes of our experiment. Okay. Which of the objects needed the most wind force for motion? Well, I can look back at the scale that I made, and I noticed vigorous. Remember, vigorous means that it took more energy, a harder force. So I noticed that I see the number 1 here, which is the softball. So we can come to the conclusion that the outcome from our experiment was that the softball of the ones that I had, now if you have a bowling ball, maybe that would be the most difficult to move. The softball needed the most wind force to move. Why is that? What did we notice about it? Just like we hypothesized, it is the densest. It is the most heavy. And remember, it didn't even have a chance to let the stitches become a factor. It only moved like this. So the stitches really didn't become as big of a factor as I predicted. So we can say the softball needed the most wind force to move. It was the heaviest and densest object. Okay? Next, we need to come to a conclusion based on the outcomes from our experiment. Which ball needed the least wind force for motion? And like I've said, this is kind of more relative because 3 of my objects were very similar in how heavy and dense they were and what their size and shape was. So if I look at my chart, soft. The least amount of wind force was number 3, the cotton ball. So is what I hypothesized what outcome we came to in the experiment? No. And it's not about being right or wrong, it's about learning. Being surprised. I love surprises. The cotton ball needed the least wind force to move. Remember, motion means to move. Now, why? It was, I thought the egg was the lightest. Like I said, they're all very similar in weight. I think perhaps it's the least dense, which means the inside has less, it has kind of like less weight inside of it, maybe than the plastic egg did or the pom-pom. Maybe the cotton material inside of it causes it to be less dense than the others. It is light and not very dense. Also, it's very soft, so that could have allowed it to move more freely on the table. It is soft on the outside. So maybe soft was more important than smooth in this experiment. All right, in our last question, were our hypotheses correct? What was different in your outcomes than what you expected? Come to a conclusion. What can you conclude about wind force and the variables like size, weight, and texture of the objects that we used? So we're coming to conclusion now. First, we're, reflecting on what we predicted. So were both of our hypotheses correct? No, they were not. And you don't need to talk about the one that was correct. You can talk about the one that was wrong or vice versa. No, the cotton ball took less force for motion to move than the egg. Yes, the softball needed the strongest, the most vigorous force to move. And then lastly, our conclusion. What do the variables like weight, texture, and size have to do with, maybe how easily or how difficult it is to move an object. So what my conclusion is that texture played a bigger role than I expected. The softer object moved further than the smoother object, which surprised me. Texture was a more important factor or variable than I expected. Then you need to talk about why. So the softer object moved the easiest. Something that we were thinking from the beginning together is that the heavier object is going to be the one that's going to be the most difficult to move and going to need the most vigorous force put on it. And that ended up becoming an outcome that we saw true. So we can conclude that weight is a big factor. The heavier the object, or the more dense, the more vigorous, we're using our vocabulary words, force it needs to move. Now, did size play a huge role? In a way, you could say yes, because the softball was the largest object and it moved the least amount. It needed the most vigorous force. However, try to think in your mind a soccer ball versus, or a volleyball versus a bowling ball. They're about the same size. But is a bowling ball going to take more force to move or less force to move than a volleyball or a soccer ball, even though they're the same size? The bowling ball, even though it's the same size as the soccer ball and the volleyball, is going to take much more force than the soccer ball and the volleyball. So size is not always going to determine how much force you need to get an object to move. Doesn't always determine how much force you'll need. Okay, and then at the very, very end, it's just kind of like a quick little check on your learning to see if you can identify the definitions for the vocabulary words that we talked about at the beginning of this experiment and throughout this experiment. Okay, so it's those same words: force, motion, hypothesis, experiment, outcome, conclusion, vigorous. You're matching the letter of the definition to its correct vocabulary word. The last question on here is to choose two of those vocabulary words and use them in one sentence. So think about a sentence maybe that you can make that has to do with this kind of an experiment or relative to this project. What sentence can you make using those words, to kind of show your reader what the words mean? Use them accurately. I hope you enjoyed this. It's a bit of a train wreck. I apologize. I hope that you have more exciting objects to use at home. And if you do, I can't wait to see what conclusions you come to, what outcomes you have that are different from mine, if your hypotheses are correct or not. And I hope you enjoyed this experiment. We'll talk more about force and motion next week. Quick reminders, we have a couple seconds left. Again, tonight at midnight, your biography project is due if you can get it done in time. That would be awesome. So that tomorrow at our 11 a.m. Zoom meeting, we can share our biography projects. I would love if we could do that. If you need more time, of course, I'll understand. Zoom meeting at 11. The link is on Google Classroom. I'll send it out in email and group me. And thank you for joining me today for special secret activity with Mrs. Keller. See you guys at 5 with Mighty Miss Malone.